So I'm making the YouTube video I wanted to find about 12 hours ago when the wife yelled out from the hall that the washing machine wouldn't start and that we couldn't do any of our laundry on this lovely Sunday. This is the door latch and lock assembly. You can see this is on the door, and it goes into here like this and that. This is a door latch assembly from a Frigidaire FRFW 3700 LWO. It was an inexpensive unit at the time. We didn't buy it because it was cheap, but because it was the only one that didn't look like a spaceship with a huge bulbous front, so it fit in our cabinet better. But they also use these on Electrolux. Electrolux makes Frigidaire, White Westinghouse, Crosley, Gibson, GE. This one is number 131, part number 1317632, but you probably know that if you found this video. Also 131763256 and 131763310. I will put all that in the description. You can see it has a little schematic on it, which is actually correct, well, as far as it goes. So that was some of the first clues. I wanted to know how the thing actually worked. There are a lot of videos on YouTube about how to replace these things, but not a lot on how to diagnose them to see whether you should replace them, or even how to hotwire your machine to run without this installed at all, with all the safety stuff disabled. So I'm going to tell you how to do all that. Now, I've shot the other parts of this, so I know what's coming up. I'm going to describe the circuitry in here quickly and how this thing operates. Then I'll show you how to hotwire your door so the machine will run without this even installed. And then we'll open it up and take a look inside, and you'll get a real good feeling, I hope, for how the thing actually works. So, as I say, this has to do three things. It has to tell the washing machine, the main board in the washing machine, and you want to diagnose this, because if this is working, then your control board in the washing machine is bad, and you just might as well throw out the washing machine because the control boards are so expensive to get. Generally, this is the problem. There is one video on YouTube on how to diagnose this. This is called the wax motor, and we'll talk about it a little bit, but that's only one part of the things that can go wrong here. So I'm hoping if you have a complete understanding of how all this works, you'll be able to kind of do your own diagnosis and make some intelligent decisions. So yeah, you go and you try to figure out so I searched for the part number, and I was trying to get a schematic, and of course all the schematics and service manuals are locked up. People want money for them. There's all this sort of rent-seeking behavior. It's all proprietary stuff. I mean, it's really frustrating for, stuff that should be readily available, so that's why I'm a big proponent of the kind of right to repair laws. Anyway, the only thing I found was this, and it's almost unreadable when you, even at a smaller size, it was almost unreadable. But this is a schematic of the inside of the door switch, and but this one only has 4 or 5 connectors. 1, 2, 3, 4, 5. So it's not this one. It may be an earlier version of this one. I have read some YouTube posts today from people who had to do some elaborate wiring to possibly convert from this kind to this kind, and I think that can be done. I also have seen from other videos that earlier versions of this have a white wax motor here, and the red one, it makes a later one, although, as I say, this one's 10 years old, and the one that's coming is 10 years old. It looks like it hasn't been redesigned in the last decade. But this one did give me some clues as far as wire colors are concerned, especially the notion that red-black, I don't know if you can read that there, is a common wire that comes in and goes to all of these other components inside the box. So that was a clue, and then I just started beeping things out and trying to analyze here, and wound up doing my own kind of wiring diagram, schematic, whatever you want to call it. These are the colors on mine. I imagine they will match yours, but these are laid out the way this is laid out. So these two are these two, black and gray. Then these 4 are these 4. And then finally these 2, is this on the screen? These 2 on the wax motor are down here. So how does this work? As I say, it has to do 3 things. It has to know that the door is closed, it has to lock the door, and it has to know that the safety mechanism to keep the door locked in case of a power failure until the drum can spin down is working. And again, you're probably here because either your machine didn't start, or it wouldn't go into high-speed spin, or it started to do, you know, it wouldn't finish a rinse, or it would stop in the middle of a cycle. So all those things are generally a problem with this device. So I drew this out this morning before I actually opened this up, but I did get it right. This is correct electrically, and the wire colors turned out to be right. But unless you open this up and look inside, you don't really get a sense of the sequence things have to happen, but we'll talk about that as we go through it. So the first thing is all the black and reds are common, they're neutral. And so they are all tied together. Effectively, if you go to the machine and probe out the plug that goes into these, on all these ones that are assigned black, red, you'll see they're all connected to each other. They all have continuity. So you can use any of these black reds as neutral. Why they didn't just bring one in like this older, I guess, version did, which would be cheaper, I don't know, except I assume that if you connect an individual neutral to each component in the box, it may be easier to do troubleshooting or something. But that is the way it is. So all of these are tied together, and we can effectively sort of tie these and ignore them. And then the kind of odd thing out is the relay coil, which is right here. Gonna draw that, and that is actually shown on the plastic here. This is this relay coil is here. This switch here is the door close switch. It's this. This is this loop here, which is the safety time delay. Bar is closed. We'll talk about that. And I guess that's all there is. So the things you want to test right away is you want to know whether your wax motor is working and whether your relay coil is working. I would start with the relay coil because it's just so easy. This one's open. I don't know what the correct value should be. I expect it's going to be a few ohms, and tomorrow when I get one that works, I will measure it and tell you. But you can put a multimeter between here, and you should get a low resistance. If you get an infinite resistance, then the coil is open and the thing needs to be replaced. And then the other thing you can check, which is there's other YouTube videos from like that one parts guy from like 2013 who says how to measure the resistance on this to see if it works. So what is a wax motor? Let's talk about that. It is it's essentially a little pellet of wax that gets heated up real hot, turns to a liquid, and when wax phase changes from solid to liquid, it expands by 25 or 30%. So it can be used to make kind of a gentle hydraulic ram in this case. So what you do is you feed 120 volts in here, this thing gets real hot, a little pellet of wax melts, and a plastic plunger slowly rises that keeps the locking teeth, the locking fork I call it, closed, so that even if the power goes off when you're in a high-speed spin, the door won't open, and it'll stay up until the pellet cools and turns back into a solid, and then this will slowly come down in a non-linear fashion. It's like slow, 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 fast, and heating up's the same way. It's kind of slow, 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 then it gets really going like a lava light or something, you know. And so if you don't get into high-speed spin and stuff, it's because perhaps this hasn't extended all the way and closed these two contacts, the orange contact and black contact here. So so there are kind of two ways you can test this, and you can test the switch as well. So the first, of course, is to measure the resistance of this to make sure it has continuity. And the other YouTube video was measuring, oh, I don't know, anything over a kilo ohm and less than maybe 2 kilo ohms is probably going to be fine. I think this one is 1.3. YouTube video said, the parts guy's old YouTube video said going up to like 1.7 is fine. It may go down as low as 1.2. Don't sweat it. If it's between a K and 2K, you're probably fine. And then another way to test it is to actually put 120 volts on this, and if you feel it right here, it'll get real hot. And you can test it and the this switch, because as this wax motor pushes this rod up, it closes these contacts here. So one thing you can do is put a beeper on this and put 120 volts on this, and wait, about a minute, and then this will beep. In fact, we can actually do that. Hang on a second. Let me get my beeper. Okay, so we're gonna connect to these two. And this won't close all at once, because as it goes up, the switch contacts kind of bounce until they make a full contact. So over here, I have 120 volts on some alligator clips connected to an isolation transformer so I don't hurt myself. You be careful. And now we can turn on the power and heat this up and wait. And if we wait a little bit, this should beep. So let's see, we all clear. Is everything? Okay, here we go. Power on. I'll put the mic over by the multimeter. And now current is coming out on that orange wire, so the control board knows that the plastic time delay plunger is in the safely locked position. Let me turn the electricity off now. And in fact, I can take these off of here because it doesn't matter. That's warm. Not super hot, but it's warm. And this will cool off now and go through the reverse process as the plunger starts falling back. And finally, I'm a ham radio operator, so I always hear Morse code as those things are opening as it's transitioning there. It's switching a full 120 volts, so I don't know how. It seemed like the contacts would get kind of beat up, but I guess there must not be too much current through there. Otherwise, everything would be super pitted, and that's fairly warm. So those are your two tests to test the wax motor and see if this plunger's going and closing this, and that's definitive. If you can do that and get the beep, then your thing is working. A resistance test is probably good enough, but if you have a question about it, that's another thing you can do. And then, of course, check the relay coil. If you want to check the door close switch, that's a little trickier. So when you energize the relay, it tries to pull this this part of the switch down, this metal down, to close this. But there is a, well, actually what happens is you press the start button and it tries to pull this down. It goes, eh. There's a little piece of plastic in the way so that it can't come down even if, even if the door is closed. And when you insert this into here, it swings this piece of plastic out of the way so that when the relay is energized, it can close all the way, and suddenly you have current on this black output wire, and the door is closed. So that does mean that the door closed wire only becomes live when the relay is energized. So one test you could do is put the beeper on the two door closed contacts, which are these. And then insert the key into the lock, and then put 120 volts on these other ones. But I would actually make up a wiring harness with some lugs, because these are so close together and you don't want to shock yourself. So, but that would let you test the switch inside here without actually having to open this up. And of course, the other test you can do is to de-energize the relay, so you can pull this out, because when the relay is energized, this is locked in. So you pull that out, and then energize the relay, and this should not beep because the door is not in. So it's a little tricky to test. I don't know whether I'd actually bother with that, but you know, if you want to test the other switch in here, that's a way to do it. So that pretty much lets you test everything in here: the wax motor, the relay coil, this switch, and if you really want to go for it, this switch. So let's say you're out in the country and you have to wait 2 weeks to get one of these as a replacement. Is it possible to hotwire the door to bypass this entirely? I mean, you have to install this as a dummy, not connected to anything, so that there's a latch to hold the door shut. But could you bypass it? Well, I did a little proof of concept of this earlier today, and the answer is yes, it is possible. I'm going to show that to you now. Okay, this is just a proof of concept on how to hotwire your washing machine. Here's ours. Here's where the switch latch usually goes for the door. And then there are the 3 buses. This is the one on top. This is the 4 one in the middle. And then this is the one for the wax motor at the bottom. We're going to ignore that for now. And the basic idea is to trick the machine into thinking that the door is both closed and locked. And if you do this and it works and you can start your washer, then you know that the problem is actually in your door latch device. I'm not suggesting that this is the best way to diagnose that. We'll look at how to trace out the actual unit safely, because this is dangerous. There's 120 volts on all this stuff, and so if you lack the necessary skills to do this kind of work, you should definitely have a few drinks first. What I've done is just taken some bus wire, which is kind of like paperclip wire. It's a number 18 bare wire. I use it in radio work, and jammed it into the plugs here. And so what you see is all of the red and blacks are common. They're neutral, grounded conductor. So I've jammed this bus wire into one of the red and blacks, and this is serving as my common. And I put 2 jumper cables on that, the yellow one and the green one. And the yellow one goes over here to my very top wire, which is black. And this is telling the washer that the door is closed. And then this green one is coming over here to the orange wire, and that's passing current to let the washing machine know that the door is locked. So now the machine is completely fooled. And if you wanted to, you could build a thing to do this, cable tie it, lash it up, jam it behind the door, stick the dummy unconnected switch in here, and go ahead and run your washing machine, I think. Certainly, this is not recommended because all the safety stuff is defeated. If the power goes out and you open the door and the thing's still spinning and you stick your hand in there and the clothes wrap around your wrist and snap it, that's not good. So, if you do any kind of messing around like this, please be careful. Now, we have ours. Let me scoot this back. We have ours on our washing machine on a Kaza smart plug because it's in this little closet, and getting back into the corner is almost impossible to switch it on and off, and sometimes it gets flaky and you want to cycle the power on it. So I'm going to tell Alexa now to power up the unit. Alexa, turn washer on. Okay, there we are. And now with these 2 jumpers, the washing machine should believe that the door is closed and locked. So, and this wasn't working at all earlier today. We couldn't even get it to start. So. And we'll turn that off right away because I don't want to flood it with water. But there you go. That's proof of concept, how to hotwire your front-loading washing machine door. So there's latches here and here, and I'm trying to prise this apart with some of these splooger sticks. But I see there's looks like a spring in here. I can see the relay coil too, which surprises me because it's kind of naked. Yeah, seems to be a spring holding the 2 halves together here. So let me try to get in here with something small. Can you see that spring right there? Keep in tension, maybe for some electrical contact. You gonna come over there? Well, there it goes. Okay. The back came off pretty easy, and now that it's open, we can really see how it works. This is the front side that you're all used to, and then now the back. And if you'll remember, these two are the relay coil, and you can see the relay coil under there. So when the relay energizes, it pulls this bar down. I'm going to call this the locking fork, and you'll see why in a minute. And yeah, taking this spring out was a mistake when I was opening it. I thought this was holding the case shut, but it really is the return spring for the relay, so it keeps it normally open unless current's applied. So when current goes away, the spring pulls it open. And then the contact from here to here is the door close switch. So this comes in the bottom and comes to this point way down here, and then the other side is this top piece of copper to this braid that comes out here. And then these two connections we'll get to in a little bit, but this tells it that the safety time delay is operating. So I have a beeper here because I was beeping this out. So we'll go ahead and put this on the door closed switch. And the problem with this is my broken one, and the problem is my relay coil is open. And I'm hoping that's why it was a failure and not just me screwing around putting 110 volts through the coil to test it today and blowing it out, you know, like a fuse. Because I noticed on the harness, the washing machine is only putting 60 volts on the relay coil. I don't know if it ever steps that up, but you know, there's a chance I blew it up. So I gotta see when I get one tomorrow. When the new one comes, I expect there to be some resistance between these two. I haven't measured any resistance between this all day, so I really do think that was the problem. Anyway, so you'll notice when the relay pulls down, it wants to pull the top of this door close switch down onto the contact, but it can't because this plastic rocker is in the way, and ordinarily this is up against the top of the case. So as we play with this, I'm going to have to kind of hold it into these U-shaped channels. But right now, see, the relay can close, but we're not hearing any kind of beep from the multimeter because again, I got this set up to beep. So I hope you can hear that with this mic. So you press the start button, and the washing machine energizes the relay, but goes, uh-oh, I don't see the door closed. And in fact, you cannot insert it now. You cannot close the door now with the start button pressed because the locking fork is down. And what happens is, of course, when you put, this is the key from the door into the lock here, into the latch. This top part, the diamond-shaped part, is the business end that pushes these two metal plates apart in here when it goes in. You've probably noticed this if you've been messing around. So these get pushed away from each other. This bottom one is just a guide. This doesn't do anything except kind of funnel it and keep it, you know, aligned in the proper position as it goes in. So you press the start button, this comes down, and he says, "Oh no, the door's not closed. I can't start, or we can't daisy chain to the next step of this thing." Because you could wire this just by daisy chaining the relay to the door closed to the heater here, and then wait for this current to come up on this. That's kind of the steps we're going to go through. Getting ahead of myself here. So let's see if I can explain this clearly. So right now, if you're holding that start button down, the locking fork is going to be pulled down by the relay, and you cannot insert you cannot close the door now at all, even if you want to. So you have to cancel it. When you cancel it, that pops up, and now you can in fact insert the latch into the receiver. And when that happens, you'll see this white plastic shoe is going to toggle backward, and that will allow this to fall all the way to the contact when the relay is energized. So I'm going to hold the ends of this here to keep it because it's going to go under pressure. I'm going to close the door, or if I can close the door. Oh, come on, you. Oh, geez, I lost my beeper. Hang on. Let's get that back on. Hold that down. Push this in. It takes a lot of force. Oops, and I don't want to hold the locking bar down. There we go. So that wasn't that wasn't a very good demonstration. But this thing has swung out of the way now. So if the relay energizes now you know the door is closed when the relay is energized. So now you can go on to the next step if you're a washing machine. Let me see if I can show that a little better, because I didn't do that very well. Let me yank it out. You see when I yank it out, it's keeping that up. Let's kind of maybe do this way. Let's see if we can get this in here so that you can see. There. I got a good shot there. Now, and the locking forks are up. So come on. Boy, it's hard to get the lever. Oh, I didn't have it. Is it going in the hole? Okay, there we go. Now we're on the hole. Okay, see that okay? I hope so. I wasn't looking at the viewfinder, but I think that was a good shot. See, now he's popping out of the thing. So now the door is closed, and the relay's energized. And the next thing that is going to happen is power is going to be applied to this wax motor, which will heat up. It gets pretty warm until it gets to a steady state, and it will change a pellet of wax from solid to a liquid, and that'll push this black plastic, I don't want to call it actuator cam up here. And what that will do is, I don't know if you can see, hope there's too much shade there. Can you see this little tab there? That is on top of the locking bar. So when this black plastic thing goes up, it'll keep the lock locked. So then imagine the power goes out, and this is all the way up, and this spring would like to pull the locking fork up and open the door closed signal. So the door closed signal is only valid when the relay is energized. That's a fine point. But this will have hooked that little lip and will be keeping the locking forks from coming up until this cools off enough that it drops slowly back all the way into this. And when this is up, these switches are closed. So this tells you that the time delay safety lock is closed, and then this tells you that it's finally open. Oh, let me push that. Oh God, don't mess that up. Gonna be okay. There we go. Woo. So let me show you, because I think it'll be fun. So here we are. Our locking fork is down. I am holding the relay actuated as though the coil were energized, and I'm going to put 110 volts here on this. I am not using the isolation transformer because I'm an idiot, so I have to be careful and not shock myself. But we'll turn this on. Let's start counting. It's 33 there. All right. So this takes a little while. It's going to heat up. And you can feel it. This does get pretty warm. And then as it starts to move, look at the contacts on this switch here. You can see they're slowly starting to come together. And there it goes. It's really phase changing now from a solid to a liquid and expanding whatever it's 20, 25, 30%. Nice, slow hydraulic action. And that's about it. Now this thing's kind of steady stating in there with whatever the heater is. I'm going to PLTT. Let me turn the power off. And you'll notice it doesn't... So let's say there's a power failure. So power's off on this, and I'm going to release the relay. But look, the locking fork is still in place. So because this is slowly cooling off and slowly coming down. And this is giving the washing machine time to spin down. Say it was in a high-speed spin. This is why it won't go into a high-speed spin if this isn't working and these contacts here aren't closed. These contacts here aren't closed. So it's still up, but eventually now, this will, get my finger out of the way. This will open up enough. Oh, did it pop? It popped. It came up. I didn't even notice it. Darn, sometimes I usually get a good spring in it. But that's, most of a minute. I'm sure you've noticed that. The washing machine's off, you think everything's finished, and you go, why can't I open the door? Why can't I open the door? And that's because you're waiting for this thing to come all the way back down. And then when this opens, it lets it know. But this is mechanically is keeping it closed, whether there's power or not, or whether the circuit boards are working or not. So it's a nice safety interlock. Big Clive has turned down a UK version of this, which is made way, way simpler and cheaper. And I'm surprised because usually, in the race to the bottom for cheap manufacturing, the United States is on top. So this is kind of surprisingly complicated and robust for what it does. But anyway, so that's it. And I hope that was reasonably clear. So you need to energize the relay, the solenoid. You need to have something inserted into the door so that current can then flow through the door closed. And then you could just daisy chain that to this heater, which would start this running up and then eventually close this and pass current through this last loop. So those would be the steps. It's closed, it's locked, and the safety is working. Jeffrey Bezos. Hey, I want to make you famous. Oh, yeah. Yeah, you're going to be part of the YouTube thing. So thank you. All right. Stay dry. And thanks to the miraculous yet terrifying efficiency of Amazon, this came in less than a day. Cost about $30, $31. And you can get this at Home Depot for $25 delivered free if you're willing to wait a little longer. We have to do laundry. So I also see some OEMs, appliance parts trying to say their parts are better, charging like $80 for this thing. But I can't believe there's more than one factory making this stuff, or that there's a good one and a bunch of Chinese knockoffs. But who knows? I just get the cheapest one you can, and if it goes out, replace it again. Got a little nice new grease in there. So the first thing we want to do is test the relay coil in this one, so I can give you a figure for what a likely, verify that it works. I can run my own diagnostics on this thing. So we'll put this on here and on here. And we get 1.3K. So that's my relay. This one's continuity, so this one obviously works where my other one didn't. And just for grins, let's run the other test and test the wax motor here. Hang on. Power on. I should really have put a stopwatch in the frame or something so you could watch the seconds tick by here instead of just a... So here, I'll jiggle my hand. Oh, well, this one's different. It just snapped on. It didn't bounce. So maybe they have made some engineering improvements. Okay, power off. That feels pretty warm. That's, I think, maybe a little hotter than the old one. So the power's off. Now we're waiting for it to cool. Oh, so that's much better. That just snaps on and off, where the other one was bouncing. So I guess pitted contacts are not a problem in this one. Maybe they did change something. I'm not going to open it up. I'm going to put it in so we can do laundry. I should have covered earlier how we figured out this might need replacing. There is a diagnostic mode on our particular washing machine and most of them, and I've got a technical sheet from my appliance guy of how to get to the error codes and stuff. In case your washing machine's similar, I'll link that up in the description along with this wiring diagram so you can download both. But essentially, I think you hold down the Option key and the start key at the same time, or pause cancel, and it goes into a diagnostic mode, and then you twiddle the mode selector, rinse, heavy wash, delicate wash, and it does different tests, and you can get an error code that flashes on our display, and we got a 41, I think, which is the control board thinks the door is open, so that's why it wouldn't start, and that's what led me to this. So I'm going to put it in. Thank you for watching this, especially thanks to the subscribers who've been putting up with me since I don't have any particular focus to this channel and keep doing one odd thing after another. I appreciate you all for sticking with me since we're closing in on 1,000 subscribers. I know most of you watching this are going to be hit and run people who just want the information to fix your washer, but if you subscribe, that's great. Anyway, thanks for watching, and like this, and we'll see you on the next one. Okay, big moment before we fight this retaining ring back in. Let's see if it works. Alexa, turn washer on. Uh-oh. Okay, it's working. And it's wet. Hey, wife, get to work. You're supposed to say, yes, dear.
Bite me.
I'm sorry you had to see that.